Welcome to the Middleware Tech YouTube channel. In this series, you'll learn about polymorphism in Python. Null code examples used in the videos will be available on GitHub. Let's get started.
Python polymorphism. So just give me 1 minute. Give me just 1 minute. Okay, guys. So what we're talking about this polymorphism part. So the polymorphism is one of the OOPS concept. So what is this OOPS concept of polymorphism and how we can implement this polymorphism OOPS concept in case of object-oriented programming approach? Let's explore into this using Python, right? Okay. So before saying anything, first I want to say that polymorphism, this name actually came from a particular word. Its name is polymer. Polymorphism name that came from a particular word called polymer. So what is that polymer? Polymer examples is, assume, just take it as a carbon element. That carbon is said to be as a polymer, and this carbon is available in 3 different states. Like is available as a charcoal, is available as a naphthalene, and the same element is available as diamond. So the same element is available in different state. That polymer carbon, that carbon element is available in different state. Okay, same element is available in different state. That the properties of a particular polymer. From there, the concept of polymorphism came. Okay, so let me give another one example. Now, if I say something like how many persons so just a question that you are with your interaction with how many person? Your interaction with how many person in full day. That means with how many persons you're interacting with full day. Full day in the sense from morning when you wake up, morning to night before going to sleep. Okay, so the thing is that I'm just to try to map the concept using a concept. Now what I'm saying is that how many persons you're interacting with full day from morning to night every day with whom you are going to interact with. So one person will say, yeah, I'm going to assume his name is take any name, okay, take Srini. So assume Srini is saying that I'm interacting with one person, his name is my friend, his friend. Then he's interacting with his sister. He's interacting with his colleague. His teacher. His mother. Family people further. And co-worker. Okay, and neighbor. And he is driving every day from one location to another location by office. Then driver. So the same this person is interacting with this many people every day. Fine. Okay. Then I'll told another person called Max. I told him, tell me please how many person you're interacting with from morning to night. So assume he's interacting with his friend and his parents and his colleague, right? And his elder brother, and assume his neighbor, right? So like this way you can get another one person. So she also can interact with some other person. Fine. Now what I want to say that assume she is also going to interact with some person. Okay. Now see here, same person is going to interact with different category of people. The full day, right? From morning to night, before going to sleep. Same person, full day is going to interact with them, right? Now see here, as a person, when I'm going to interact with my friend, that is a different communication than if I'm going to interact with my parent. And that will be slight different communication if I'm going to interact with my colleague or my boss. And that will be different communication than if I'm going to interact with my brother or sister. So the thing is that same person is going to communicate with different category of people. correct? And the person who is going to communicate with different category of people, and each and every communications are different. You cannot make the communication with your friend as same as the communication with your parent. So each and every communication is different, right? So that is the concept that I want to say here. Similarly, when you're going to write a Python program, inside a Python program, you have multiple methods. Inside a Python program, you have multiple methods. Let's see, this is my Python class. Python class is A. Okay. Inside my Python class, I have multiple methods. Assume this is one method, M1. I have another one method, M2. I have another one method, M1. So if you see here, same method. That is the point. Same person is doing different tasks. That means the same person is interacting with different people, and each and every communication is different. So same person is doing different task, different communication. Same person is doing different communication with different people. Same person is doing different communication with different people. That is the point. Inside your class, in object-oriented programming approach, inside your class, it's possible that same method can do different tasks. Similarly, inside your class, it is possible that same method is doing different tasks. Method name is same. Same person is doing different tasks, different communication. Same like that. Inside your class, same method can do different tasks. Then that concept is called polymorphism from object-oriented programming approach. Right, that we're talking about, that polymorphism is one of the important concept of object-oriented programming approach, where you'll find that the same method is doing different task. Okay, same method is doing different task. Now if you can use same method to implement a different task, so this is now you'll say that okay, we have done inheritance. That is one of the OOPS concept. So what is the advantage? We can get reusability. Okay, we have done encapsulation. So what is the advantage? We can hide an object attribute value inside an object. Okay, now I'm talking about we are going to do polymorphism, another OOPS concept. So what is the advantage? Advantage is that the polymorphism advantage mostly not from a developer perspective, but from compiler perspective. So I'll show you how the advantage come into picture. So I'll show you. But this polymorphism concept, if you want to compare polymorphism with Java, they are also the same thing. Or not only Java, take about some other language. They're also the same thing, that same function we can use to implement different tasks. So if you can implement or can use same function to implement different tasks, that is said to be the polymorphism. So in Python, we can use this concept. So we can say that Python support polymorphism. Fine. Okay. Now this polymorphism, now the question is that how Python support polymorphism? What are the different classification is there in polymorphism? right? Let's explore this OOPS concept using some example, right? And this concept in Python is slightly different than Java. Okay, so just see here, please. First point I want to say that the topic that I told you, polymorphism, means polymorphism. First point I told you that it is one OOPS concept. Is OOPS. The first point. Second point is that that this OOPS concept, this polymorphism means same method will implement different tasks. Same method will do different tasks. Okay, so how we can implement them, right? Okay, let's see here. Types, if I say types, this is actually two types. Tell you, type. One is called function overload or constructor overload. Function overloading or constructor overloading, this is one. Sometimes you see compile time polymorphism or same name, or we can say, okay. And another one is there. For second type is called function override or constructor. Okay, so this polymorphism we can divide into two categories. One is called function overloading or constructor overloading. Another is called function override or constructor override. So out of these two types of polymorphism, first one, not supported by Python. Second one, supported by Python. You have to remember that function overloading and constructor overloading not supported in Python. The first you should know what is this function overloading, constructor overloading, and why it is not supported in Python, right? So let's see some point on this. I'm going to execute. Similar types of problem we can. So let me come to this. Type number one is this one. Number two is this one. Fine. Okay. Okay. Now here So here if you see that we have to know how this function overloading constructor, what is this function loading, why it is not supported in Python. This you can define from some other language perspective point of view also. See, what is this function overloading? Function overloading means same function name, same function name, same function name based on type of argument one of the function get selected during compile time. During compile time, right? Same thing based on constructor overloading. If I say based on argument, one of the constructor gets selected during compile time. Based on type of argument, one of the constructor gets selected during compile time. This is called function overloading or constructor overloading. How it is? Let me see an example. Which one example? Let's see. I have one class. As in this is my class. And inside the class, I have one method. Assume I've defined M1 method. Right? And inside this M1 method, I have declared one data type. Inside this M1 method, you can initialize one value like comma ID. Okay, so self dot ID equal to value. Okay, I have one. Assume I have another method def m2. So this is also same name method. Okay, and here first argument self, and here also I'm using ID. Here I'm using self dot ID equal to ID. Okay, now if you see this example, if I say like this, I have these two methods. Okay, and inside the class, now what I'm going to do, I'm going to create an object of the class. An object of the class. Creating an object, I'm going to call this method. Okay, now assume I have another one parameter pass. Okay, and then here I'm going to use self dot pass equal to pass. And this is the object that we have created. A equal to this, and then what I'm going to do, A dot M1. Right, I'm passing some parameter like 20. In the second case, assume I have only one argument, assume for the time being. And in the second case, I'm going to pass A dot M1. I'm going to pass that A dot for value. Now, if you see here, what is the problem? I'm talking about function overloading or constructor overloading that is not supported in Python. First, I'm talking about what is this function overloading. For case of function overloading, we have a same function name. Same function name, but it will do the different task based on type of argument and number of argument. So assume this is doing the addition between one. Assume this is ID equal to ID and self dot ID1 equal to ID1, and you can write here sum equal to ID plus ID1. Here also you can do the same thing. Control C, same thing, Control V. Now the point is that when I'm going to do the addition, what is the problem? Assume first time I've used 20 and 40. Second time I'm using 2.35 and 5.40. The problem when I'm going to call with an argument, same method name. This method is doing the addition. Assume this method is doing subtraction. Same method but doing different task. But the problem is that based on type of argument, number of argument. If you're doing in Java, it was working fine because in Java there is a concept of int and float. That is, there is a concept of type. The type, variable type, I am going to pass from here based on that one of the function gets selected during compile time. I'm talking about in Java. In Java, you're going to define the type. If it is an int you're going to pass, then it is going to select a particular method where you're going to take the parameter as an int. So this method is going to do the addition between int. If you're passing the float, then it will take a particular method where it is taking a float as an argument and it is going to do the addition between float. So same method, one method is doing the addition between int, another method is doing the addition between float. So both the methods are doing two different tasks. But if it is in Java, it is fine. But in case of Python, there is no type concept. There is no type, right? In Python, how this variable is initialized. Based on the variable type, the variable will be either int or float. So if I'm going to pass like this, no effect, because there is no concept of type concept in Python. And it will always select the last implementation of the method, not the, if the same name, if it find same name and method is available 2 or 3 method inside the class, only last implementation of the method it will select, right? So there is no concept of type, as well as if we have same name multiple method, then the recent method will be selected by the compiler or Python virtual machine. That's why we cannot implement the concept of function overloading or constructor overloading in Python. Same like that. I already told you last, if you remember, I told you that if I have multiple constructor, then the recent constructor only Python by Python version will take. All the remaining constructor will no use. Right? So that is the point. That this function overloading or constructor overloading not supported by Python. Why? So that I'm talking about here. This is the definition of function overloading. Okay, so this is a definition. But in Python, since Python have no static data type concept and right there, and only the recent method, only the recent method is recent method or constructor, recent method or constructor is selected by PVM. That's why, since Python don't have the static data type concept. Static data type means not dynamic. Static means int, float, double. I cannot declare implicitly, right? We have the concept of dynamic typed language, right? So since Python is dynamic typed language, so we don't have make a type concept, right? Type concept of type concept, right? And only the recent method constructor is selected by PVM when we have multiple same name method inside a class. When we have multiple same name method inside the class. So assume, just think it about only method, not constructor. Same thing applicable for constructor also. Right? So since Python have don't Python have Python does not have type concept, and only the recent method is selected by PVM when we have multiple same name method inside a constructor. That's why there is no concept of, that's why we cannot or we don't have the concept of function overloading or constructor overloading in Python class. That's why this overloading not supported by Python. Not supported by overloading not supported by Python, right? So this is the point. But Python support the concept of the second type of polymorphism supported by Python. Second type of polymorphism is supported by Python. Second time, this one. That is called a function override or constructor override. This is supported by Python. Right. So how function override or constructor override supported by Python, right? We have to explore in this. Next, if you want to add something more, you can add, right? Okay. So what I'll do is that before going into that function override or constructor override, okay, so let's take a break for 10 minutes, 15 minutes, 20 minutes, and then we'll start with this function override or constructor override. So it is one type of polymorphism itself. So polymorphism means same function is doing different task. Polymorphism means same function is doing different task. So first point is that in case of function overriding, and that is supported by function, it's fine. In the case of function override, I want to talk about. So here, in case of function override, we have we have the concept of inheritance. That means we will do function override when we have the concept of inheritance. Inheritance means I should have a base class and I should have a derived class. And I should have a derived class that will extend the base class. This concept should be there. That means there must be a concept of inheritance in case of function override. First point. Second point is that as I have a particular method inside a base class M1. I'm talking about same method name. Second point is same method name. Same method name means I have one method here in the base class. Same method I have in derived class. Same method, see here, same method name. So, right, based on, so what we say like that the method gets overridden from base class to derived class with my own code. So in the base class, this is a method definition, right? Assume in this method you have written some text like print. You can write some code is in class this. Now what I'm going to do in the derived class, I have defined one method, and the method name is same. And in the derived class, inside the method I'm writing some other code. Print this is in class B. And now we got right now what you find, and then we say that if we have same class method in base class as well as in derived class, base class method I have written some code and derived class method I have written some code, then we say that the method overridden from base class to the derived class with my own code. Okay, if we have same method name in base class and derived class, then we say that the derived class method is overridden from base class with its own code. Right now here, if I create an object of the base class here I have the base class EA, right? So if I'm creating an object of base class like obj equal to this is a base class object. You can create a base class object like this, right? So if I create an object of base class, right, and using this base class object, I'm calling the method. So call this method obj dot m1. So there is no concept of polymorphism because it's normal. You have a class, and using this class, you're calling this method. Right? It's a normal flow. Right now, what I want to do is that I'm going to create a derived class object. Forget about this normal flow. Now I'm going to create the object of derived class object obj equal to derived class object we have created. Now I'm calling obj dot m1. When I'm calling obj dot m1, now see it's a derived class. It's a derived class, right? So it's a derived class. So when I'm calling obj dot m1, so which method to call? It's a method of the base class, because base class method is also there. So which method to call? It's a method of the base class or method of the derived class, right? Which method to call? So that is being decided during runtime, and in here in this scenario, where is the concept of polymorphism come into picture? In this scenario, where is the concept of polymorphism come into picture? Like, see here, both the class contain same method name. Now, what is the concept? What is the advantage if I'm going to write the code like this? I'm saying this is a function overriding. These are examples of function overriding. Then what is the advantage? Where is the advantage? See, the point is that when I'm creating an object of derived class calling m1 method, which m1 to call, that is decided during a runtime. Okay, and for compiler will treat it as a single m1 method in both the class. It will not count as a 2m1 method that is defined in the base class. For compiler perspective, the function overriding concept is being one type of you can say advantage from compiler perspective. So this function override that I'm going to talk about here, we have to say like we are going to use this function overriding when there is a concept of base class and derived class. Base class and derived class should have same name method. Then we say that we have overridden the method from base class to derived class with its own code. When I'm calling the object creating the derived class method, then which method to call, that is decided during runtime. So from that point of view, we say it is a runtime polymorphism also. But most of the scenario, we define this concept in Python as a function overriding that the method. So this is completely from compiler perspective, that the method gets overridden from base class to derived class with its own code. So we should always use this first function overriding implementation in our code, so that it will create good performance optimization from compiler's perspective, because it counts both the method as a single method from compiler perspective. This is the maybe basic idea about function overriding.